The recording started before I got set up. Oh, I love recording tutorial videos. I hate recording them 5 or 6 times before I'm finally happy with them. You're getting this one, whether it's good or terrible, so I hope it goes well. My name's Jay Wilson. I am a technical success manager at Domo, and while we're all locked down during coronavirus season, whatever, I'm going to the Domo dojo and answering questions that kind of capture my interest and maybe share something new about the Domo platform. Have you ever been posed with the question, how does this variable affect that variable? I'm sure you have, right? Let's imagine that this is a list of customers. I know their total sales. I know how long they've been a customer. I know how tall they are. I have some data representing where they live. And I want to say, okay, which of these three variables have the highest impact or are the best predictors of revenue? Everybody has had that question. Everybody, including Nighthawk. Nighthawk wanted to build the correlation coefficient as a beast mode. What is a correlation coefficient? Well, the Pearson correlation coefficient says or calculates how two items are related. And the value will range between -1 and +1, where -1 means not related or strongly inversely related. And +1 means strongly related in the same direction. And 0 means there's no relationship at all. That's a terrible description. Let's take a look at this correlation plot. Stats, I'm not going to lie, was a long time for me. I'm not a statistician, so I'm kind of only regurgitating what I barely half remember. If you are a statistician, please don't get mad at me. I think this data set's talking about cars. And what it says is, let's look at this intersection here. If as the number of cylinders in a car go up, the miles per gallon drops precipitously. There's a strong inverse relationship between cylinders and miles per gallon. Alternatively, though, as the number of cylinders goes up, the horsepower has a strongly positive correlation. The number of horsepowers go up. And that kind of makes sense. Let's take a look at gear and carburetor. I assume that says carburetor. I know nothing about cars. I ride a bike everywhere because I'm good for the environment. This 0.27, what that says is there's a very weak correlation at best. The number of gears in a car is not a strong indicator of the carburetor. I assume that's what CARB stands for. I don't know. But that's a correlation plot. The point of a correlation plot is to compare multiple metrics against each other to say which ones have the strongest relationship to another. And that's what Nighthawk was asking. He's saying, how do I calculate how strong a relationship there is between revenue and duration? Now, our man Dean Wagnerin said he couldn't use one of a standard SQL function called correlation, and instead he calculated the math by hand. How cool is that? I'm not a statistician. I don't know if this is right, wrong, or indifferent. I'm going to assume that his math is right. But the challenge I had is I said, oh, well, I want to be able to compare 1, 2, 3, 4 different metrics against each other. And I don't want to have to write 16-ish, 12. I don't want to have to write a whole bunch of versions of the same beast mode, right? Because in Dean's work, he says take X, sum X plus Y, where each of these is a different metric. I don't want to have to write 5 or 6 different permutations of the same beast mode. How can I restructure my data so that I can afford to be lazy? That's the question that I'm going to answer. How can I restructure the data so that all of my metrics, all the metric values are contained in a column called X and Y? At the end of the day, what I'm going to end up with is a data set like this, where I have 13 observations, and I have a row containing duration and duration, a row containing the metric values for duration and height, a row containing the metric values for duration and location across each of the 13 observations. That's the goal. Let's see how we do it. I mean, if you've watched any of my other tutorial videos, you know the answer already. You just do a cross apply. That seems to be the answer to everything. Nihar is going to shoot me twice. That's a joke. Our database team at Domo would obviously prefer it if you did not use cross-apply for all of your solutions, where basically you multiply all of the rows in one data set times all of the rows in another data set. That's pretty expensive in terms of saving data or saving space, disk storage, that's the word. But, you know, sometimes you got to do it to build a correlation plot. So what do? The first thing I do is I use the collapse columns function. I want to collapse the data such that I end up with one row per observation, and I have 13 observations, per metric. I have 4 metrics. I'm going to end up with 4 times 13 rows, which is 39. We're going to have to run a preview and test that math later. Then I'm going to pull my data into streams, where I rename the metric column as X, and then I create a copy of the data set where I name the metric column as Y. I'll use my join column equals 1 method to do a cross apply. So join where the observations are the same, and then join where the joined columns are the same. So let's work backwards real quick. The result of my collapse column here, I have 4 different metrics, and for observation 1, I have 4 rows. If I have 13 metrics, 13 times 4, yeah, that's 39. Cool. Here, I take the same data, and I just rename the columns as X, and here I'll rename the columns as Y. When I do my cross apply on observation my output data set will be, if each observation has 4 metrics and I did a cross apply, then I do 4 times 4 is 16 rows per observation, and 16 times 13 I can't. But the reason why we're doing this is because now I can look at duration and I can say, oh yeah, the duration was 185 and the height was 54. Somewhat related. The duration was 185 and the revenue was 603. Oh yeah, that seems like a strong relationship, or whatever. I can calculate that across my multiple observations. And again, that's the goal of this ETL, is to put the different metrics on the same line, but have them called X and Y instead of the actual metric values. So easy. Just pop in correlation coefficient. The math that Dean did. I didn't make any changes here. I assume his math is accurate, or their math is accurate. Now, how does this help you? The reason why this helps you is now you can say, hey, I'm interested in knowing which metrics had the biggest impact or have the strongest relationship to revenue. So now when I filter on revenue, I can see, oh yeah, the correlation for duration is 0.57. Yeah, it's pretty strong. The correlation between revenue and height, however, is 0.87. Very strong relationship. Revenue is 1. Revenue to revenue is 100%. That's obvious. And the relationship between revenue and location is 0.27. So that's kind of weak. So I would say location has no impact on revenue. And that makes sense because I typed it in randomly, whereas the other ones I actually tried to make them have a positive correlation. Now this visualization allows you to answer, for this revenue, for this metric, which metrics have the strongest relationship? It does not look like this correlation plot. But what's going on here? I've got metrics on the x-axis and metrics on the y-axis. Well, guess what? That, friends, is a pivot table. And if you weren't paying attention at Domopalooza, I'm saying it again, they've released pivot tables in Domo. All the Excel folks started cheering. So now I can put metrics on my y-axis, metrics on my x-axis. If I take out my filter, now it looks like a correlation plot, just no color coding. And if I sort alphabetically, then 1 goes through the middle because location, height. Yeah, this is gorgeous. So there you go. Nighthawk posed the question, how do I calculate correlation coefficient in a beast mode? And Dean did a great job of answering the question. I wanted to expand on this because all Dean's calculation does is it says what is the relationship between revenue and duration. In real life, your analysis is usually across 5 or 6 or 20 different metrics. So you want to be able to compare all of them at the same time. Dean's calculation would have required us to create 20 or 30 versions of the same beast mode. Jay Wilson, he's mega lazy, so he said, how can I change the structure of my data so that I can have one beast mode that compares all of my metrics at the same time? And we did a cross apply to get that done. My name's Jay Wilson. I am a technical consultant at Domo, as well as a technical success manager. If you have any questions, reach out to me. This is how I spend my Friday nights these days. I'm super excited to engage with you guys on the Domo Dojo, or you can reach out to me at jae.wilson@domo.com. j.wilson@domo.com. Oh, it's been a long week. Thanks so much, guys. Catch you later.